Let's understand the code for product of array except self. So we'll be using nums, which has 1, 2, 3, 4 numbers. So it's an array. So the corrected output is 24, 12, 8, and 6. So because each position is the product of all other numbers, let me explain you clearly. Okay, how do we write this? So we write this in a simpler manner like this. 1, 2, 3, 4. What did I say? Each position is a product of all other numbers. So we can write, instead of 1, write all other numbers product, which is 2 into 3 into 4, comma. Instead of 2, write all other numbers. 1 into 3 into 4. And instead of 3, write all other numbers. 1 into 2 into 4. Instead of 4, write all other numbers. 1 into 2 into 3, which is 24, 12, 8, and 6. Okay? So now let's do this. So to solve this, you can easily say that we can do division, but the interviewer gave a condition that you can't do division. Division, what do you mean by division? So we can directly find this using by just multiplying 1, 2, 3, and 4, you'll get 24. Right, 1 into 2 into 3 into 4 is 24. So we by just so you can just divide everything like 24 divided by 24, 12 divided by 24, 8 divided by 24, 6 divided by 24. So this is 1, this is 2, this is 3, this is 4. So you can do this, but you can't do this because the interviewer gave a condition that you can't do division. So how do we solve this? We will solve this in a simplest manner. So the basic thing is we will create an array, an empty array called res. So this is an empty array. Okay, that's it. So first we'll do left product. To understand this, what we are doing, we have to deeply understand why we are taking left and why we are taking right. So the reason why I am taking left is, so we have these numbers 1, 2, 3, and 4, right? So now try to multiply the left of the number, except that number. So what is on the left? Nothing. So write 1. So so the left of this 2 is, it is just 1. So write 1. Okay. So what is the left of 3? 2 and 3. So write 2 into 1. Okay. What is the left of 4? Which is 3 and 2, which is 3 and 2 and 1. Okay. Left numbers. Okay. Then we will do right. Okay. Then we multiply both of them. Then you will get the final result. 1, 1, 2, and 6. Okay, this is how you get this. So in code, what we have done is generally we will take 1. So because when we had 1 here, what's the previous number? So instead of thinking that, we'll just take the first index number has 1. So that this is a resultant array. So this is a resultant array. Okay. So 1. Then resultant array of position equals to previous number into the previous number. Okay, this is how you get. So when the we we can see here uh, the resultant array of with index 0 is 1. Okay, we got 1. So 1 into 1 is 1. Okay, this is how you wrote here. And I equals to 2. So what happened when you had 2? This is 0 and this is 1 and this is 2. So when you had 0 index, then you got 1. Okay, you got 1. When you take 1th index, you got 1. When you take second index, you got 2. When you take third index, you got 3. Okay? This is how you got 1126. This is just a simple code. What does it do is, it is the resultant array which will create, multiplied by the nums of I minus 1. So the original array. Okay? I just showed you here. Okay? The second thing is right products. What do you do with the right products? I'll just explain you easily right now about the right products. We have 1, 2, 3, and 4, right? So what we'll do is we'll multiply all the right numbers except itself. So we'll do as 2 into 3 into 4. Okay, 2 into 3 into 4, except 2, multiply all other numbers on the right, which is 3 into 4, except 3, multiply all other numbers on right side, which is 4, except 4, multiply all other numbers on right side, which is nothing but take it as 1. 4 threes are 12, 12 twos are 24, 3 fours are 12, okay? 4 and 1, right? So now multiply this one, now multiply this one with this one. You will get 1 comma 1 comma 2 comma 6, which is nothing but multiply this with this with this with this, which is 24, 12, 8, and 6. So this is the result which we got in the first place. 12, 24, 12, 8, and 6. So the code is pretty simple. Here, in the step 2, when we come across the code, we will take suffix. So it is just a variable where we take 1. So the suffix will be 1. So 6 into 1 equals to 6. And we have 4 as suffix because suffix into num of I. Everybody gets confused at this place where nums is nothing but 1, 2, 3, 4. Okay, nums is nothing but 1, 2, 3, 4. And I didn't explain the code here. I just gave you the basic understanding, which I thought someone, when I was learning, someone could teach me. Now I'll explain you the same stuff, coding. So we only care about the left side of index. So we say res of 0 is equals to 1 because there is nothing to the left of index 0. So we use 1. So we used that. So then we run res of I equals to res of I minus 1 into nums of I minus 1. This means to get the product of everything, on the left of I, take the product we had for the previous index, which is res of I minus 1, and multiply it by the previous number in the array. I hope you understand. Then we go to this. So let's try run step 1 with nums of 1, 2, 3, 4. So for res of 0 equals to 1. So for I equals to 1, res of 1 equals to res of 0 into nums of 0, which is 1 into 1, which is equals to 1. For I equals to 2, res of 2 equals to res of 1 into nums of 1, which is 1 into 2 equals to 2. For I equals to 3, we have res of 3 equals to res of 2 into nums of 2, which is 2 into 3 equals to 6. So after this loop, res equals to 1126. Now at each index of I, Res of I is the product of all the numbers to the left of I. Okay. So now when you go on the right side, so the step two now here we handle the right side using a variable called suffix. So here you can see the word called suffix. So we start with suffix equals to 1. Think of suffix as product of all the numbers to the right of the current index. So we go from right to left, from right to left. Okay, we go from right to left for each index of I. So we multiply res of I by suffix. So we multiply res of I by suffix. Then we update suffix by multiplying it with nums of I. So next time it includes this current number as well. So when you see this dry run, step two with the same example, we have 1, 2, 3, 4, right? Then this equals to 1, 1, 2, 6 we had previously. Then suffix equals to 1. Then we go from right to left. When I equals to 3, this of 3 equals to 6 into 1, which is 6. And the suffix is 1 into 4, which is 4. So we are just following this code, okay? When I equals to 2, this of 2 equals to 2 into 4, that is equals to 8. Suffix equals to 4 into 3, that is equals to 12. When I equals to 1, this of 1 equals to 1 into 12, that is equals to 12. Suffix equals to 12 into 2, that is equals to 24. When I equals to 0, this of 0 equals to 1 into 24, that is equals to 24. So the final result is 24, 12, 8, and 6, which is exactly the product of all the elements except the one at the index. So this is the full function. First loop fills res with the left products. Second loop multiplies, as I said, second loop multiplies in the right products using suffix. So together they give us the product of array except self in big O of n time and constant extra space. So when you see the summary of this, I know this video is pretty long, but step one, res of I becomes the product of all elements to the left of I. Step two, we multiply by the product of all the elements to the right of I using one variable suffix. That's it. If this helped you finally understand the code step by step, please like the video and follow me for more easy DSA explanations. Thank you.